We have all seen mesmerizing pictures of Jupiter taken using powerful telescopes from here on Earth. But what does this gas giant look like from up close? What mysteries lie within the complex patterns on this planet's surface? For the longest time, these were questions we could only hope to one day get answered, and that day came when Juno entered Jupiter's orbit and took real images of storms that brew up on its surface. Let's find out together what NASA discovered from these images from mission Juno. Jupiter is one of the most interesting planets in our solar system. It is a gas giant, meaning most of its composition is gases like hydrogen and helium. It also happens to be the largest planet in our solar system, but you already know all that. What is more fascinating is how Jupiter protects Earth. You see, even though Jupiter is located around 628 kilometers away from Earth, it deflects the paths of asteroids that could potentially hit Earth. And Jupiter has been doing so for billions of years. This fascinating planet holds many mysteries that astronomers and scientists have strived to uncover. Unfortunately, though, it is not easy to send a spacecraft to study Jupiter. The giant planet is too far away. Plus, it emits radiation that is dangerous for space probes. There have been 9 missions where space probes have been sent to study Jupiter. But the mission we will be discussing today is the Juno mission. What did NASA discover from the images obtained from this mission? Keep watching to find out about Juno. Mission Juno was a highly complicated mission by NASA with the aim of studying Jupiter in great detail. $1.5 billion were spent on Mission Juno with the hopes of unraveling some of the mysteries surrounding the gas giant we call our neighbor. The journey of the Juno probe started on the 5th of August 2011. The probe was launched using an Atlas rocket from Cape Canaveral, Florida. Thankfully, the probe was sent into outer space successfully. With the launch, Juno's lengthy mission began. The Juno probe was designed especially to survive the harsh conditions around Jupiter. It was also equipped with advanced equipment needed to study the gas giant, so it was ready to take on the extreme challenges awaiting it in the darkness of space. The first part of the mission was to get Juno to Jupiter, a task that would take 5 years to accomplish because of the vast distance the probe had to travel to get from Earth to Jupiter. The trajectory. Before the Juno probe could reach its destination, it had to follow a very complicated trajectory. After the probe exited Earth's atmosphere, it was set to take a trajectory that would propel it farther away from Earth than the orbit of Mars. Then the probe had to perform a deep space maneuvers that sent it on a return journey to Earth. Why? Well, the Juno probe needed a gravity assist to gain enough speed to reach Jupiter successfully. In October 2013, nearly 2 years after its launch, Juno zoomed past Earth, catching a glimpse of our home planet once again. The probe stole a tiny amount of Earth's momentum. Juno was now venturing on a path to Jupiter at a speed of 3.9 kilometers per second or 93,000 miles per hour. For 2 years, Juno continued on its course until eventually it reached its destination and began the ultimate approach. During this time, the probe was placed in safe mode to keep only essential functions running in order to preserve fuel. The first close-up glimpse of Jupiter. In January 2016, the Juno probe was finally nearing its destination. As it made its ultimate approach towards Jupiter, the probe helped us see the gas giant and its moon up close. When Juno was 4.8 million kilometers away from Jupiter, it took a time-lapse video that showed the 4 moons of Jupiter orbiting it. It is breathtaking seeing these celestial bodies that are insanely far from us in such detail. Arrival. Finally, the wait was over. In July 2016, Juno had traveled through the far reaches of space for 5 years, and it had finally reached its destination, Jupiter. But the probe was traveling at extremely high speeds as it closed in on the gas giant, much faster than any spacecraft before it. So it needed to slow down to enter the orbit of Jupiter. To do this, Juno performed various maneuvers until it achieved an elliptical orbit around Jupiter. The orbit of the probe was carefully designed to ensure that it was a safe distance away from the harmful radiations that were coming out of Jupiter. At the same time, the probe was near enough to the planet to make accurate observations. The orbit was also designed to let the spacecraft get as close as 3,100 miles above the cloud tops of Jupiter. But this only happened sometimes. Although Juno had arrived at its designated destination, the mission was far from over. It was now time to begin observing Jupiter and learn more about the planet, what we saw. In August 2016, Juno completed its first orbit of Jupiter, and it has continued to do so ever since. These pictures of Jupiter look like a work of art with mesmerizing patterns and beautiful colors. But what these patterns are made of are colored structures. The bluish cloud structures on Jupiter are unique to it. They cannot be found anywhere else in our solar system. But that's not it. Juno also successfully captured aurorae on Jupiter's south pole. The probe captured the aurorae in infrared light, which isn't visible to us humans. Jupiter has the strongest aurorae in our solar system. No other planet comes close, but the cause behind these aurorae remained a mystery for a long time. That is, until Juno helped scientists study it in greater detail. Jupiter's aurorae are not caused by the energy from the sun, as is the case here on Earth. Juno showed us that it is likely that they are instead caused by some processes happening inside the gas giant. As Juno reached its closest point to Jupiter's surface, it also took observations of the clouds themselves. The images taken by the probe show how these colorful clouds are violently swirling around on Jupiter without any solid surface anywhere near beneath them. The clouds are mainly made up of ammonium salts. But what's more fascinating is that they extend down for miles and miles, making Jupiter's surface an ocean of gases. Juno also showed another unique site of Jupiter, its North Pole. What the images showed was terrifying yet beautiful. The infrared images showed a gigantic storm raging on the North Pole. This one big storm is surrounded by 8 other smaller cyclones. Just to put it into perspective, each one of these smaller storms is capable of covering the entirety of North America. Such is the chaos on the gas giant. The red spot. Juno also captured the red spot of Jupiter during its orbit in July 2017. The red spot is an anticyclone that has been raging for a long time. The high-resolution photos gave us much-needed details of the phenomenon to marvel over. Juno also assessed the depths of the red spot and estimated that its roots extend as deep as 200 miles. That is as much as 100 times deeper than the oceans of the Earth. This goes to show how grand the largest planet in our solar system really is. The discoveries. Juno discovered various other storms on Jupiter during its voyage around the planet. This showed that the planet is even more chaotic than we thought. The probe also successfully detected the internal magnetic field of the gas giant. This was a significant finding, because this is the first time we have discovered an internal magnetic field on a planet besides Earth. The Juno mission has been one of the most significant space exploration missions in history. It brought forth great discoveries and gave us a deeper understanding of our solar system and the planets within it. Juno's future. Originally, Juno was only supposed to operate until 2018, but seeing at the capabilities of the probe, the mission timeline has been extended. Now, the probe is expected to operate until September 2025. The future of the Juno mission is bright. The probe's observations will help us understand Jupiter even better in the coming years. From understanding the formation of the planet to discovering its deeper layers, Juno will be instrumental in our future pursuits of studying our solar system. We would like to thank you for watching our video. We hope you enjoyed it and learned something new about the Juno project and Jupiter. We'd love to hear your thoughts and questions on this topic, so feel free to share them with us in the comment section below. Be sure to hit the like and subscribe buttons to see more content like this in the future.